Okay, so we are going to be doing solving systems by substitution. The first thing you need to know are just the steps. Anytime you're solving systems by using substitution, you need to isolate one of the variables. Substitute the expression from step 1 into the other equation. The resulting equation should have only one variable, not both x and y. Step 3 is solve the new equation. This will give you one of the coordinates. Step 4 is substitute the result from step 3 into either of the original equations. Step 5, solve for the other coordinate. And step 6, write the solution in an ordered pair. Excellent. So we're going to go through many things. Some easier ways to kind of look at it is step 1, if you're not given a variable already alone, find the easiest variable to solve for, get it alone. Step 2, substitute the expression into the other equation and solve for the variable. And step 3, substitute the numerical value you found into either equation and solve for the other variable. Write the solution as x, y. The two are exactly the same, just this is concised into 3 steps, whereas the other one has more steps. So right here we have y equals x minus 3 and y equals negative x plus 5. Since they are both equal to the same variable, we can just set them equal to each other. So I have, excuse me, let me fix that, x minus 3 equals negative x plus 5. As you can see in this, now I only have x, so I'm just going to solve for x. I'm going to add x to both sides. Cancels out, so I have 2x minus 3 equals 5. And add 3 to both sides. 2x equals 8. Divide both sides by 2. X is going to equal 4. So in my ordered pairs, I have x is 4. And I'm just going to plug it into either one of those equations. So, excuse me, y equals 4 minus 3, so y is going to equal 1. To check this, I would say 4, plug in my answers. So I'd have 1 equals 4 minus 3, 1 equals 1, that's correct. I would have 1 equals negative 4 plus 5, 1 equals 1, that's correct. Here's another example. Again, y equals negative 2x plus 5 and y equals 5 minus 2x. So they are both equal to y, so I can just set them equal to each other. So I'm going to move this kind of out of the way. I have negative 2x plus 5 equals 5 minus 2x. Add 2x to both sides. They both cancel out, so I have 5 equals 5. 5 does equals 5, no matter what. So that tells me it's going to be infinite many solutions. When a number equals itself, that's how you know it's infinite many solutions. If the number equals another number, it's no solution. Great, so now if you have one equation where it's y equals 2x minus 1, and then one equation where it's not solved for a variable, this is how you would do it. You first isolate one of the variables, then you substitute the expression from step 1 into the other equation. So this just gives you can pause it and go step by step and read it. It's the same exact steps as I showed you previously, but the example to the right is different. So feel free to pause that and look through it. I'm going to continue and do some more examples. So I have 2x minus 3y equals negative 1 and y equals x minus 1. Notice that I have y equals, so a variable is all by itself. So I'm going to take this and I'm going to plug it into that y. So I have 2x minus 3 times x minus 1 equals negative 1. When I then distribute, so I have 2x minus 3x plus 3 equals negative 1. Combine like terms, negative x plus 3 equals negative 1. Subtract 3 from both sides. Negative x equals negative 4. And then I cannot have a negative variable, so I'm going to divide both sides by -4 to get x equals 4. Now I just have to plug 4 in for x to solve for y. So I'm going to come over here, and you can use that with either equation. I'm going to do the second equation because it's already y equals. So y equals 4 minus 1, y equals 3. So my solution would be 4, 3. Here's another example. I would recommend pausing it, working it out, and then pushing play again and watching to see if you did it correctly, and if you didn't, where you might have gone wrong. So again, I have y equals 4x minus 11 and negative 4x plus 3y equals -1. So I'm going to take this right here, 4x minus 11, and plug it in to the y of the second equation. So negative 4x plus 3 times 4x minus 11 equals -1. Again, I'm going to distribute. So I have negative 4x plus 12x minus 33 equals -1. Combine my like terms. So I have 8x minus 33 equals -1. Add 33 to both sides. 8x equals 32. I'm going to divide both sides by 8. 32 divided by 8 is 4. So my x is 4. And again, I'm going to plug it in. So 4 times 4 minus 11. 16 minus 11. So my y is going to be 5. So 4, 5. And again, you can just plug those in to make sure that is correct. Finally, if you have two problems or two equations that neither one of them is equal to a specific variable, you can solve for a variable and use substitution. And again, you can pause and look over this same exact 6 steps from the very first slide with an example, or you could just move on and I will show you an example. However, typically when you have two equations set up in standard form like this, you might want to use elimination, which we will go over in the next video. So in this case, I have x minus y equals 20 and 2x plus 3y equals 0. So I'm going to solve for a variable to get one variable all by itself. So I have x minus y equals 20. I'm going to solve for x. I'm going to add y to both sides. You could solve for y. It's just going to be an extra step because you can have a negative variable. So I have x equals 20 plus y. So I'm going to plug all this in to that x. So I have 2 times 20 plus y plus 3y equals 0. So 40 plus 2y equals 3y, plus 3y equals 0. Combine like terms. So I'm going to have 40 plus 5y equals 0. Subtract by 40. y equals -40. Divide both sides by 5. Y equals -8. So I'm going to come back up here, and I'm going to have y equals -8. So it's something, comma, -8. Now I'm going to go back to one of my original equations and plug -8 in for y. So I'm going to use 2x down here plus 3 times -8 equals 0. 2x minus 24 equals 0. Add 24 to both sides. 2x equals 24 divided by 2. X is going to be 12. So then there's my solution. I hope this helped you solving systems by substitution.